Welcome to my project bazaar.com. Let me discuss about the process detection of thunderstorm using datamining and image processing. The detected thunderstorm from depends on weather and then the limited spatial and temporal extension, either dynamically and physically. This proposed method should give the accurate prediction. Using the clustering and wavelet transform from to successfully predict the thunderstorm resulting with very high accuracy. We have to detect the thunderstorm for forecasting of this service whether feature in advance to reduce the damages. The thunderstorm is very interruption associated with the heavy rains, lightning, thunder, thick cloud and gusty surface winds. Actually, thunderstorms have spatial area for few kilometers with lifespans less than an hour. The thunderstorm and lightning is sudden electrical explosion manifested by the blaze of lightning with muffled sound is one of the most spectacular scale weather phenomena in the atmosphere. Thunderstorm produce the lightning in this kills more people every year than damages. The prediction of thunderstorm is most complicated task in weather forecasting. This various researches are being carried on for casting of this severe reduced image. Many of the researchers proposed various methodologies like STP, MOM, CG, LM and QKP, DBD model and so on for the detection, but neither of them could be provide the accurate prediction. The proposed system is gathered satellite images obtained from the dataset in order to predict whether the cloud images produces the thunderstorms or not. And then next we see the flowchart of our process. In this flowchart we have to mean the taking the input image using the thunderstorm as in satellite images. In this, from the satellite image we have to predict the reduction of the input images in this thunderstorm is obtained is not or not. This is the efficient method to using the Hall wavelet and the K-means and then like a segmentation process of to detecting the thunderstorm. Finally, we have to detect the pixel counting to compare the threshold values from. We have to segment the input image to from. We have to predict the output image. Then we have to take the whole processes one by one. In this, we have to original image of our process. It is very effective clustering technique to predict the transformed image of our input. In this clustering should be varied many cluster levels with pixel values like input images like is called K-means clustering. The cluster method is very help to analyze the next step of our process. In our process, select the number of levels to replicate the images at each level of our input image. The next process we have to see the Haar wavelet transform. One of the transformation process to domain conversion process is efficient in Haar research for the transform the input image from time to frequency domain of input image. This process is very helpful further process like such as threshold clustering and counting calculations for input images of thunderstorm. The another important process is the threshold segmentation. In this segmentation, to set the threshold values for the required pixel value in the input image from the segmentation to be obtained from the color conversion is very helps to us. This part of process in this final process of thunderstorm prediction. In this process, threshold values to be segmented the image accurately after the process of the Haar wavelet transformation. The final process is detecting the thunderstorm. In this, using the number of pixels obtained in and the threshold value to compare to from the we have to predict the thunderstorm using compared with the number of pixels in output from threshold and initial threshold value in process of prediction. Set a particular level to predict the all possibilities in the thunderstorm inputs. In this MATLAB main window, we have to concentrate on four things: command window, workspace, and command history. Also, the current folder is to be loaded the important files of our process, like executed files. The command history, command window is like executed visually viewed in the main files of our process. In this command history is nothing but the stored in any process obtained in the command window in this our process. The workspace is nothing but the storing the values and variables usually in the coding part of our process. The next we have to run our process. The GUI.main, right click and click run. This is the window for our process to obtain the final result. First of all, we have to browse the button clicking. This is the process of taking input for our process. I have to take third image. Click open. This is the representation of taking input image of our process. Next process, we have to click the k-means. In k-means process, we have to use the hue, saturation and intensity HSI images to obtain the number of cluster levels that's to be obtained, and the 4 levels to be pixel labeled cluster index to be final output for our process. This is the presentation of final output of our process, the k-means clustering. Next process, we have to click the hard transformation. In this hard transformation, we have to taking the input image to the wavelet transformation to domain transformation, and then inverse this process from. We have to take the input images to transform the hard transformation. Is to be still run. Take the input image to transform the wavelet format, and then we have to calculate the thresholding. After thresholding calculation, we have to threshold the input image to be viewed in the calculate the white pixel of our process. The next process, the final process to identification the thunderstorm or not in our input image. After clicking the identification, we have to take the input image as a pixels to be segmented using the threshold value. This is the representation of the input image is in a thunderstorm or not. Click OK. The analyze button is nothing but the analyze the segmented output is how accuracy is to be obtained. This is the comparison graph for different methods of existing techniques is TP, MOM, CG, LM, QKP and TVD from proposed techniques. How range is to be increased, the segmented performance analysis to be viewed. Now we have to conclude our process. In this process, we have to predict the thunderstorm in different levels of thunderstorm images using the clustering and R-wave transformation methods from the predicted with average accuracy. For all possibilities of taking input images, thunderstorm images, the final process to be very efficient using the threshold segmentation to be counted the pixels from the input images to be accuracy calculated. The final graph is like performance analysis segmentation is very helpful to analyze the results in the segmentation results to be compared with existing methods of our process. The existing methods values to be entered in statically in the to be graph in our process. The reduction of thunderstorm is to be particularly able to predict the possibilities in the thunderstorm inputs. The process of predicting the output is to be predict the thunderstorm using compared between the multiple pixels and output from the initial threshold values of our process. The final process models is very efficient from the other existing process.